8 times over the last 800,000 years, the summer sun over the far north has dimmed, and 8 times the ice has answered. Snow stopped melting across the tundra of Canada and Scandinavia. It packed down into glaciers, and the ice sheets began their slow march south. That dimming is happening right now. Summer sunlight in the Arctic is sitting near the weakest point in its entire cycle, and the ice is doing the opposite of everything it has done before. What nobody understood until recently is that the trigger was pulled and the planet did not fire. This is East Antarctica at a research station called Dome C, more than 2 miles above sea level and hundreds of miles from the nearest coastline. A drilling team spends years pulling cylinders of ancient ice out of the dark, one section at a time, stacking them in refrigerated crates like evidence at a crime scene, which in a sense is exactly what they are. Every one of those cylinders is a slice of a vanished sky. When snow falls on Antarctica, it traps tiny pockets of air between the flakes. The next snowfall presses down on it and the next, until those pockets are sealed into solid ice and buried under a mile of the stuff. Break the ice open in a laboratory, sample the gas inside, and you are breathing air that last touched the surface of the Earth when mammoths were walking across Siberia. The Dome C core reaches back roughly 800,000 years, and what it shows over and over is a heartbeat. Carbon dioxide climbs to somewhere near 280 parts per million. The planet warms, the great ice sheets retreat, and for a few thousand years, the world looks something like the one outside your window. Then carbon dioxide falls to around 190 parts per million. The temperature drops, and ice a mile thick buries Chicago, Toronto, and Stockholm. That is 8 full cycles, 8 ice ages, 8 thaws, all of them running like clockwork. And the reason it runs like clockwork is that it is being driven by an actual clock. The mechanism was worked out by a Serbian engineer named Milankovitch, and the strange thing about it is that it has almost nothing to do with the sun getting hotter or colder. The sun stays about the same. What changes is the Earth. Our orbit around the sun is not a perfect circle, and the shape of that ellipse stretches and relaxes over roughly 100,000 years. Our axis is tilted, and the angle of that tilt rocks back and forth over roughly 41,000 years. And the axis itself wobbles like a slowing top, tracing a full circle every 26,000 years or so. Stack those 3 motions on top of each other, and the amount of sunlight arriving at any given latitude in any given season rises and falls in a pattern that repeats for as long as the solar system holds together. Pay attention to this next detail, because it explains everything that follows. The temperature of the whole planet is not the number that drives an ice age. The number that drives an ice age is how much sunlight lands around 65 degrees north during the northern summer, along the line that runs through central Alaska, northern Sweden, and the middle of Iceland. Here is why that line and no other. That band of the globe is where almost all of the land sits: Canada, Scandinavia, Siberia, and the shallow seas around them. The southern hemisphere at the same latitude is nothing but open ocean, and ocean does not hold snow. So if you want to build an ice sheet, you build it up north, or you do not build it at all. Now imagine a summer in northern Canada where the sunlight is a little weaker than usual, not dramatically weaker. Just enough that the snow which fell last winter does not entirely melt before the next winter arrives. A patch survives. That patch is white, and white surfaces throw sunlight back into space instead of absorbing it, which makes the ground around the patch colder, which means more snow survives the following year, which makes a bigger white patch, which makes it colder still. The whole trigger is a little snow that refuses to leave. Run that feedback for a few thousand years and the patch becomes a glacier. Run it for a few tens of thousands, and the glacier becomes an ice sheet 2 miles thick sitting on top of Hudson Bay, so heavy that it presses the crust of the continent down into the mantle. Sea level drops by roughly 400 feet. The floor of the North Sea becomes dry land. The land bridge between Siberia and Alaska rises out of the water. The whole planet reorganizes itself around a patch of snow that did not melt. The Milankovitch clock decides when the sunlight weakens. The snow does the rest. So here's the part that should be keeping paleoclimatologists awake at night. Summer insolation across the northern latitudes is currently near its minimum. You can calculate that on a laptop, and every group that runs the numbers arrives at the same answer. The dial that has started every ice age in the ice core record is sitting almost exactly where it sits when ice ages start. And there is no sign anywhere on Earth of a new glaciation beginning. Instead, the Greenland ice sheet is losing mass every single year. Arctic sea ice is thinner and covers less water than it did when satellites first began watching it. Glaciers in the Alps, the Andes, and the Himalayas are in retreat almost without exception. The snow patch that is supposed to be quietly surviving its first summer in northern Canada is not surviving. It is not even close. The trigger was pulled. Nothing happened. If you are finding this interesting, take a second to subscribe, because these deep time mysteries are what this channel does every week. Enter a team at the Potsdam Institute for Climate Impact Research led by a physicist named Andrzej Ganopolski. In 2016, they published a paper in the journal Nature that went after the question directly, and their approach was to stop treating sunlight as the only variable. Because sunlight is only half of the equation, the other half is the blanket. Carbon dioxide traps heat. It is a measurable property of the molecule, and it has been understood since the 1800s. So, the amount of snow that survives a northern summer depends on two things working against each other, which are how weak the sunlight is and how thick the greenhouse blanket is. Weak sunlight under a thin blanket gives you an ice age. Weak sunlight under a thick blanket gives you nothing at all. What the Potsdam team did was map the exact relationship between those two numbers. They ran an ensemble of simulations, tuned the model against the ice core record, and drew a line. On one side of the line, the ice sheets grow. On the other side, they do not. And when they tested that line against the past 8 glacial cycles, it explained every single one of them. Then they turned the model on the present. The answer they got is one of the strangest results in modern climate science. Using pre-industrial carbon dioxide, the level the atmosphere held before anyone burned coal at scale, their simulations suggest that glacial inception was narrowly missed before the beginning of the Industrial Revolution. Read that again, because the timing is the entire point. The miss did not happen because of us, it happened before us. At 280 parts per million, with the sunlight as weak as it currently is, the Earth was sitting right on the edge of that line. A slightly thinner blanket, and the snow in northern Canada would have started to stick. A slightly deeper orbital minimum, and the ice sheets would already be forming. The planet walked up to the edge of a 100,000-year glaciation and stopped there, for reasons that had nothing to do with human beings. Which raises an obvious and uncomfortable question. How close is close? Researchers at University College London went looking for an answer inside the ice cores using a technique that amounts to astronomical matchmaking. They searched the record for the warm period whose orbital configuration most closely resembled our own, and they found one. It is called marine isotope stage 19, and it happened roughly 775,000 years ago. The sunlight then looked like the sunlight now. The geometry lined up. That warm period lasted somewhere between 10.5 and 12.5 thousand years, and then the ice came back. Our own warm period is now about 11,700 years old. The team, led by Cronus Tsidakis, laid out what that comparison implies. If carbon dioxide had followed the trajectory it followed in that ancient interglacial, sitting down around 240 parts per million, the current warm stretch would be nearing its end. Their estimate was that we would have somewhere in the neighborhood of another 1,500 years before the glaciers began their return. On a geological clock, 1,500 years is close enough that the alarm is already ringing. Except that carbon dioxide did not follow that trajectory. It is currently above 430 parts per million at its seasonal peak, and across the entire 800,000-year ice core record, it never once climbed above roughly 300. There is nothing in the archive that looks like this. The blanket is thicker than it has been at any point the ice can remember. At that concentration, no glacial inception is projected to occur. Not soon, and not for a very long time. Now, before you file this away as settled, there is a serious scientific disagreement running straight through the middle of it, and it deserves better than a footnote. In February of 2025, a team led by Stephen Barker at Cardiff University published work in the journal Science that pulled the orbital cycles apart and gave each one a specific job. Precession, the wobble of the axis, drives the melting. Obliquity, the tilt, drives the freezing. Eccentricity, the stretch of the orbit, sets the overall 100,000-year rhythm. The pattern they found was so reproducible that they could predict when each warm period of the past million years would begin and how long it would last. When they ran that pattern forward, they did not get an ice age that is overdue. They got one that is early. Their conclusion is that without human emissions, we should currently be sitting in the middle of a stable warm period, with the next glaciation beginning roughly 10,000 years from now as the tilt of the axis continues to decline. So which is it? 1,500 years past due or 10,000 years early? Both answers come from careful people working with good data, and the honest position is that the field has not resolved it. What every one of these groups agrees on, including Barker and his colleagues, is the part that actually matters. Whatever the natural schedule was, it no longer applies. Which brings us to what we have actually done. David Archer and Andrei Ganopolsky worked through the arithmetic 2 decades ago in a paper with a title that has aged unnervingly well, describing fossil carbon as a movable trigger. Their finding was that the emissions humanity has already released, on the order of 500 billion tons of carbon, are enough to postpone the next glaciation by at least 50,000 years. Push the total to 5,000 billion tons, which is roughly what is sitting in the ground as recoverable coal, oil, and gas and glaciation, could be prevented for the next 500,000 years. That is 500,000 years without an ice age. Our own species is somewhere around 300,000 years old. We would be handing the deep future a planet in a climate state with no analog anywhere in the last 2.5 million years of the record. It is tempting to hear all of this and conclude that we got lucky. An ice age is, after all, a catastrophe. Ice sheets bury cities, sea level swings by hundreds of feet. The wheat belts of the northern hemisphere turn into tundra. Nobody is arguing that the return of the glaciers would be pleasant, except that nothing about this qualifies as a rescue because the glaciers were never a danger on any timescale a human being can care about. Even the most aggressive estimate gives us 1,500 years of runway, and glacial inception is a slope you slide down across tens of thousands of years rather than a wall you hit. The thing we canceled was never going to touch anyone alive. The thing we did to cancel it is warming the planet on a timescale of decades, and that part is already happening outside the window. So the real question is not whether stopping an ice age counts as good news. The real question is what it means that a civilization a few thousand years old has taken hold of a mechanism that has been running for 2.5 million years and pushed it off course before it fully understood how the mechanism worked. The ice cores at Dome C will keep sitting in their freezers, holding 800,000 years of a rhythm that no longer describes the world. Somewhere in northern Canada, right on schedule, a patch of snow is failing to survive its summer. It is the smallest possible signal, and it is the one the entire planet used to listen to. If deep time and the hidden machinery underneath the climate are the kind of thing you want more of, the next investigation is waiting on the screen in front of you, and it goes somewhere far stranger than an orbit and a patch of snow. Thank you for watching. If you enjoyed this video, please feel free to like and subscribe. And if you would like to continue watching more of my videos on science mysteries, you can click the video on the screen now.